Thanks to satellite navigation, it is now next to impossible to lose your way in modern times, as it can pinpoint your location to within few meters, wherever you happen to be on Earth, just in no time. The Indian Regional Navigation Satellite System, now called the Navigation with Indian Constellation or NavIC, provides the users of the Indian subcontinent extending to 1,550 kilometers around the Indian landmass with a position accuracy of better than 10 meters and a timing accuracy of better than 40 nanoseconds on a 24/7 all-weather basis. All this may look simple to the user. However, in the background is operating a very complex process, starting with the satellites up above the world and ending with the users with the receiver devices on ground. And connecting the two is the lifeline of any satellite navigation system, the control stations on ground. The space segment, that consists of a constellation of 7 satellites with onboard atomic clocks along with their downlink signals. Of the 7 satellites, 3 satellites are placed in the geostationary Earth orbit, while 4 satellites are placed in inclined geosynchronous orbit. The network of satellites work as space landmarks, as we always know their positions, just like the landmarks we have on Earth. Each of the NavIC satellites weighs approximately 1,425 kilograms and have been designed, fabricated, integrated and tested at the U.R. Rao Satellite Center based in Bengaluru. The navigation satellite payload, the equipment that essentially provides the broadcast signals, is developed by the Space Applications Center located in Ahmedabad. Second is the ground segment that works 24/7 to maintain and monitor the NavIC constellation and manage the operations of the satellites and its associated facilities. The ground segment comprises of the ISRO Navigation Center (INC) at Bengaluru and Lucknow, established by the ISRO Telemetry Tracking and Command Network (ISTRAC). The INC, along with the IRNSS Network Timing Center, IRNSS Range and Integrity Monitoring Stations, IRNSS CDMA Ranging Stations, the Navigation Control Center and IRNSS Data Communication Network enables position, navigation and timing data broadcast by the satellites. The ground segment also comprises of the IRNSS spacecraft control facilities at Master Control Facilities, Hassan and Bhopal, which maintains the NavIC satellite constellation. The third and last segment is the user segment. This consists of receiving devices that you carry with you for navigation. All the 3 segments work together to provide position, navigation and timing service to the users, be it on the surface or above it. The IRNSS satellites transmit a time-stamped radio signals in 2 different frequencies at 1176.45 MHz and 2492.028 MHz respectively, which helps in providing timing information to the receiver for acquiring the signals. For time accuracy, the satellites transmit their signals controlled by onboard atomic clocks, which have a stability of better than 10 to the power minus 13. This means that unlike the ordinary clocks, which tend to lose or gain a few seconds after a few days, this atomic clock is stable enough not to lose or gain even 1 second for almost 10,000 years. It has to be so accurate because even an error of 10 nanoseconds could lead to a degradation of position accuracy by about 3 meters. These rubidium atomic frequency standards (RAFS) are used for accurate time stamping of navigation signals. The ground-based IRNSS receivers sense the time-stamped signals emitted by IRNSS satellites. On ground at the ISRO Navigation Center, the IRNSS network time is generated through an ensemble of active hydrogen masers, cesium clocks, and passive hydrogen masers. The INC ensures that all the onboard clocks are synchronized to the IRNSS network time. The IRNSS network time is in turn steered to Indian Standard Time IST, generated by the National Physical Laboratories, New Delhi, who are the official timekeepers of the nation. The IST has the required accuracy, stability, and traceability to the universal time. The IST division of NPL generates time and frequency traceability to ISRO through a two-way satellite time and frequency transfer TWSTFT system, which is used for comparing two remote clocks with an accuracy of about 1 nanosecond. TWSTFT signal is transmitted in the Ku band from one station to other station using a geostationary satellite GSAT-8 spacecraft. The INC gets one-way ranging data from IRNSS range and integrity monitoring stations located in 16 different sites spread across the country, including Port Blair and Lakshadweep, and one located outside the country in Mauritius. INC also gets two-way CDMA ranging data from stations located at 4 different locations, one each at Hassan, Bhopal, Jodhpur and Shillong, which are equipped with an 11-meter full-motion antenna system to achieve better accuracy in orbit determination. The data received from all these stations is remotely monitored and controlled through the IRNSS monitoring and control system from a centralized console at INC. This enables to achieve range accuracy at sub-meter level, which helps us to always know the accurate orbit determination of the satellites. International laser ranging data is used for the purpose of calibration. INC generates the navigation data that needs to be broadcast by the NavIC satellites. All elements of the IRNSS ground segment are linked through reliable communication links called the IRNSS Data Communication Network. The mirror facility called INC2 is also operational at Lucknow. This will ensure redundancy and uninterrupted availability of the NavIC system. The NavIC receiver consists of single and dual frequency receivers on a wide variety of platforms. All ISRO networks like MCF, IceTrack, SHAR, NAV use NavIC timing receivers for network time synchronization, satellite launch and tracking operations. 5 national power grid sites are now installed with NavIC receivers for power grid control, measurements and monitoring applications. NavIC is also now being integrated into Qualcomm's Snapdragon 720G, MediaTek Helio M70 and Broadcom BCM 47765 mobile chipsets. The day isn't too far off when the entire nation will switch over to NavIC, making India truly Atmanirbhar.